Mars, a cold, dry, rust-colored world, wasn't always this way. Billions of years ago, it may have looked surprisingly like Earth. Ancient riverbeds, dry lake basins, and mineral deposits all point to a time when liquid water flowed across its surface. Scientists believe that Mars once had a thick atmosphere capable of trapping warmth and supporting a stable climate. But somewhere along the line, something went terribly wrong. The once blue skies of Mars faded into a thin haze of carbon dioxide, and its oceans vanished into space. The question is, what exactly happened to Mars' atmosphere? To understand the mystery, we need to look at the planet's core. Early in its history, Mars had a molten iron core that generated a powerful magnetic field, just like Earth's does today. That magnetic shield protected the planet from the sun's intense solar winds, streams of charged particles that constantly blast through the solar system. But as Mars cooled over time, its core solidified and the magnetic field weakened. Without that protection, the atmosphere became exposed to the full force of the solar wind. Over millions of years, those high-energy particles stripped away the lighter gases from Mars' upper atmosphere molecule by molecule. NASA's Maven mission confirmed this process, showing how solar storms continue to erode what little atmosphere remains. The result is a planet with air so thin that it can support liquid water on the surface for long. Any exposed water instantly boils away or freezes. Gravity played another role. Mars is only about half the size of Earth and has weaker gravity, which means it was never able to hold on to its atmosphere as tightly. Once the magnetic shield disappeared, gravity alone couldn't stop the gases from escaping into space. What remained was a thin layer of mostly carbon dioxide, less than 1% as dense as Earth's atmosphere, far too little to keep the planet warm. The loss of atmosphere transformed Mars from a potentially habitable world into the frozen desert we see today. Temperatures now plunge below -60 degrees Celsius, and the air pressure is so low that even if you stood on the surface, you couldn't breathe without a spacesuit. Yet the ghost of its past still lingers. Polar ice caps, traces of ancient deltas, and minerals that could only have formed in water remind us that Mars once had what it takes to sustain life. Scientists are still piecing together the full story. Some suspect that large impacts from asteroids accelerated the loss by blasting huge amounts of gas into space. Others study how volcanic activity may have released greenhouse gases that briefly warmed the planet before vanishing again. What is certain is that Mars' atmosphere was not lost in a single event, but through a slow, relentless process driven by the sun, gravity, and time itself. Today, missions like Maven and Perseverance continue to search for answers, and maybe even signs of ancient life that once thrived under a thicker sky. Understanding why Mars lost its atmosphere doesn't just reveal its past. It also helps us predict the future of other planets, including our own. It is a cosmic reminder of how fragile atmospheres really are, and how a small change can turn a living world into a silent one.